In this session, we will discuss radiometric dating. Our goals will be to summarize this line of evidence that seems difficult for a short-age time frame. Radiometric dating involves analysis of rock samples to calculate an age in years. First thing to understand is radioactive decay. An unstable parent radioisotope breaks down to form a daughter product, a stable element. This decay occurs at a measurable rate, resulting in a ratio in a rock sample of parent isotope and daughter isotope. The decay follows a predictable decay curve. This decay curve is illustrated here in the diagram. In a certain amount of time, which is the half-life for that element, half of what is there decays. And so it forms a curve like you see here. You take your rock sample, you measure the amount of parent element and the amount of daughter product, and that gives you a ratio. And from that, you can look at this curve and calculate the age. In the other diagram, the ages calculated from radioisotopes are given in this figure. So you can see the top of the Precambrian is 541 million years. The top of the Paleozoic is 252 million years, and so on up through the scale. So let's look at radiometric dating methods. One of these is carbon-14. Many people don't realize carbon-14 is quite different from the other methods. Carbon-14 can only be used for dating organic material, that is, carbon. It's only good for late Pleistocene, only to about 50,000 years on the standard time scale. Carbon-14 comes originally from nitrogen. In the upper atmosphere, cosmic rays strike nitrogen and change it from nitrogen to carbon-14. This becomes part of carbon dioxide, which becomes part of the plants, and we eat it, and then our bodies are radioactive with this carbon-14. And then when the animal dies, the carbon begins to decay back to nitrogen. The other methods are quite different. Potassium-argon, argon-argon, uranium-lead, lead-lead, etc. You cannot date fossils with these. They're only for dating minerals. They have very long half-lives in millions of years. The important question for us here is, does radiometric dating give us absolute time? In reality, there's no instrument you could invent that could take a rock sample and give you a date in years. The instrument documents the ratio of parent to daughter isotope. So when you have that ratio, you then make some assumptions and calculate a date. The date is correct only if the assumptions are correct. In particular, the date is correct only if the changing ratios are the result only of passing time and not of any other influences. Each of these dating methods depends on assumptions. They may not give true time. Those of us who have confidence in the Bible believe that these methods are not giving us a true date in years. Okay, let's look at the carbon-14 assumptions. The assumptions are that the decay rate has always been constant, the amount of carbon dioxide in the atmosphere has been constant, the amount of cosmic rays entering our atmosphere has been constant. Of these different methods, carbon-14 is the easiest to explain from a creationist point of view, because these things that have to be constant may very well not have been constant at the time of the flood and because of the flood. Here's a graph that somebody made to calibrate carbon-14 ages to real time. And you won't have time to analyze this here in this talk, but look at this diagram in the book and you can see how it works. Making some reasonable assumptions about what happened during the flood, we can relate real time to this radiocarbon time. The other methods, like potassium-argon, uranium-lead, lead-lead, these have partly different assumptions. One assumption is the decay rate has always been constant. Another one, the rock has remained a closed system, which means that there was no chemical interchange and no mixing with other rocks. Another assumption is the radiometric clock was set to 0 when the rock was deposited in its present location, and the sequence of ratios of isotopes was produced by time and not by other factors. However, the decay rates are not inherent in the isotopes themselves. They are affected by distance from the Earth to the Sun. Now, don't think that this explains all the radiometric dates, but it does tell us that there are factors from the outside the isotopes that affect the decay rate. In your book, there are sidebars that help to explain many different things. And so we'll just look at the sidebar for radiometric dates, other than carbon-14. First of all, data. You can measure the decay rates of each specific isotope. And we can measure the isotope ratios from rock samples. Those are our data. Okay, how about the interpretation? Conventional science, the interpretation will be the evolutionary origin of life forms is assumed. and this requires very long time spans. This requires that the radiometric time scale be at least roughly correct. Gives no incentive to seek other interpretations of the radiometric data. For those of us who believe in interventionism, we assume a much shorter time frame, and we predict that the conventional assumptions are wrong, or there are other discoveries to be made. This point of view gives incentive to search for better explanations for the data. An interventionist or creationist approach gives incentive to search for better explanations for the data.